All right, everyone, welcome. Today, we are diving deep into a technology that's not just coming for your field, it's going to completely redefine it. We're talking about artificial intelligence. We're going to get past the hype and look at how AI is becoming a real, fundamental tool for managing, securing, and honestly, unlocking the true value of health information. So here's our game plan. First, we'll nail down what AI actually is. Then, we'll unpack how it learns from the very data you'll be in charge of. We'll explore how it gets its senses to understand clinical info, see it in action in the OR, and finally, we'll tackle the big, tough challenges that you, as future data guardians, are going to have to face head on. Okay, let's jump right into section 1. What is artificial intelligence? Because before we can talk about its impact, we've got to pull back the curtain and demystify what this technology is really all about, especially in a healthcare setting. This is the big question, isn't it? I mean, this is the idea that really drives so much of the innovation we're seeing. Can a machine truly mirror the complex, nuanced thinking of a trained medical professional? It's a fascinating question. At its heart, AI isn't really science fiction. Encyclopedia Britannica puts it pretty simply. It's just getting a computer to do tasks that we'd normally associate with intelligence. In our world, in health information, this isn't about building a conscious machine. It's about creating a tool that can classify, analyze, and predict things with an efficiency that's, frankly, superhuman. Now, look at the key word here, system. This is so important. AI isn't just a piece of code floating in the cloud. In healthcare, it's a whole ecosystem. It needs skilled people, that's you, to create the right procedures and to make sure the data it learns from is clean, accurate, and reliable. The quality of that health information, well, that's the bedrock for everything else. So, how does the system actually work? Well, it pretty much follows 3 core steps. First, it learns by just soaking up massive amounts of data. Think of it analyzing millions of medical codes. Then it reasons by using rules to spot patterns, maybe to predict a patient's risk of being readmitted. And here's the magic part. It self-corrects. It looks at real-world outcomes and uses that feedback to get smarter and more accurate over time. But, and this is a huge but, we have to remember its limits. The AI we're using in medicine today is what we call narrow AI. It can be brilliant, absolutely world-class, at one specific task, like finding tiny anomalies on a scan, but it has zero intuition. It doesn't feel empathy. It's an incredibly powerful tool for analysis, not a replacement for human judgment. All right, on to section 2. Let's look under the hood. How does an AI actually go from a bunch of raw data to a useful insight? How does it learn from the very health information you're going to be managing every single day? There are really 2 main ways an AI learns. First, you've got supervised learning. That's where we're the teacher. We feed it a data set that's already labeled, like thousands of medical images where a pathologist has already pointed out, here's the tumor. The other way is unsupervised learning. This is where we just let the AI go exploring. We give it a ton of raw, unlabeled patient data until it finds something interesting. And it might discover hidden patterns or new risk factors that we never even knew existed. Then there's this third way, reinforced learning. This is all about trial and error. So imagine you're training a surgical robot. It tries to make a tiny movement. It gets feedback. Was that good? Was that bad? And it learns from that feedback. You do that millions of times, and eventually it refines its actions until they're nearly perfect. And this is where things get really, really powerful. Deep learning. It uses these incredibly complex structures called neural networks. They're actually modeled after the connections in our own brains to process information in layers. This is the engine behind the most amazing stuff, from turning a doctor's spoken notes into perfect text to predicting disease outbreaks just from EHR data. Okay, so we get how an AI learns. Now for section 3, how do we give it senses? Let's explore how these systems actually see and hear all the messy, unstructured information you find in a hospital. So, AI's version of sight, that's computer vision. A perfect example of this in healthcare is a tool called DeepHealth. It's an AI that's been trained to analyze mammograms. It can actually highlight suspicious areas for a radiologist to take a closer look at. It's like having a second pair of expert eyes on every single scan. And AI's hearing is natural language processing, or NLP. And for you, as an HIM professional, this technology is an absolute game changer. This is the magic that turns a doctor's rambling spoken notes into clean, structured, codable data in the electronic health record. It can scan millions of patient charts in minutes to find people who are perfect for a new clinical trial, a job that would be literally impossible for a human to do. So, from thinking and sensing, we are now moving to doing. In Section 4, we're going to look at robotics in the operating room and see how AI gets its hands to actually interact with the physical world. You know, robotics isn't just one thing. It's this meeting point of engineering, computer science, and AI, all coming together. In healthcare, the whole point is to create devices that can do physical things, like assistant surgery, with a level of precision and steadiness that can actually boost a surgeon's own natural abilities. Now, let's be super clear about a system like the famous Da Vinci robot. Let's talk about what it is and what it isn't. Its main job is to give the surgeon greater precision. It is absolutely not autonomous. A human surgeon is in 100% control 100% of the time. This is so important. It is an advanced tool that makes an expert better. It is not a replacement for that expert. Okay, we've seen all the incredible, promising stuff. But now we need to have a serious talk. As future health information management professionals, as the guardians of patient data, it is absolutely essential that we understand the challenges and the really tough questions that come with this power. This is a massive operational and ethical question. It's one we have to ask before we even think about plugging an AI into a real clinical workflow. Because the honest answer, if we aren't incredibly careful, is yes. It absolutely can be. And here's the core of the problem. An AI learns from the data we give it. And if our historical health data reflects existing societal biases, and, let's be honest, it often does, the AI will learn those biases. It might even make them worse. It could start making different recommendations based on things it sees in the data that we never intended. As HIM professionals, your job of ensuring data integrity and fairness, that is the first and most important line of defense. For anyone going into this field, this question is everything. It's the whole ballgame. As we start feeding these incredibly powerful systems with our most sensitive patient information, our responsibility to protect it grows exponentially. And the risks here are very real. When you have enough data points, true anonymity becomes almost impossible to guarantee. These huge AI-ready datasets become a goldmine, a huge target for bad actors, and things like data retention policies become more critical than ever. As the managers of this information, upholding privacy and security is your most sacred duty. And this all leads us to the final and maybe the most important question of all. See, AI is no longer just a tool in a toolbox. It's becoming a teammate in delivering care. So your biggest task as future leaders and information managers will be to write the rulebook for this new team. How do we validate an algorithm's advice? What are the protocols for trusting it? How do we make sure a human is always in the loop in a meaningful way? The answers you come up with for these questions won't just shape your careers, they're going to define the future of medicine.